Hello, my name is Zion Thomas, and today we're going to be doing an example problem of creating the Taylor series of a function. And essentially, the Taylor series definition, it represents the approximation of a power series using the derivatives of the function. You can write this as summation of the function to the nth derivative of a, which is where you're centering your approximation, over n factorial times x minus a to the n. Okay, and our problem today is, as you can see, 1 over 1 minus x to the third, and for this problem, a equals 0. So when a Taylor series is centered on 0, it's called a Maclaurin series. Maclaurin series definition, very similar to the Taylor series. A few adaptations. So it's the nth summation of 0, nth derivative of 0 over n factorial times x to the n. Okay, so let's start finding these derivatives. F of x equals 1 over 1 minus x to the third, which can also be written as 1 minus x to the negative 3, which makes it easier to do the derivative. So the first derivative, f of x equals, you have to do chain rule, so negative 3 times 1 minus x, negative 4, and then you do the derivative of the inside, which is negative 1. It's negative 1. So it equals 3 times 1 minus x to the negative 4th. And then the second derivative equals, take negative 4 down, so negative 12 times 1 minus x, negative 5th times negative 1, which equals 12 times 1 minus x to negative 5th. And you just keep taking the derivatives, and then we'll plug it into the Maclaurin series definition. So negative 60 times 1 minus x to the negative 6 times negative 1 equals 60 times 1 minus x to the negative 6. Alright, so let's start plugging these into the Maclaurin series. Okay, so start with f of a plus first derivative of a times x over 1 factorial plus second derivative of a times x squared 2 factorial plus third derivative of a times x cubed or 3 factorial. So let's write this out. F of a equal 1 over 1 minus a, which is 0. So 1 minus 0 cubed equals 1. So for the first term is 1. Right up top, 1. And then f prime of a equals 3 over 1 minus a, which is 0. To the fourth equals 3. So for here you have to multiply by the x and divide by 1, which is 3x. Second derivative, a equals 12 over 1 minus 0. The fifth, which equals 12. Multiply by the x squared, divide by 2 factorial. So it is plus 12x squared, 2 factorial, or the 1 factorial here just so you can see, and 0 factorial is just 1. Third derivative of a equals 60 over 1 minus 0, 6, which equals 60. Here, multiply by x cubed, plus 60 x cubed factorial. Alright, so now let's see if we can find the pattern, so we can find the general term. So here you can see that, here you can see the 3, I got this by doing n plus 2 factorial divided by 2, 3 here. So 1 plus 2 factorial, which is 3 factorial. 3 times 2 is 6, divide that by 2 and you get 3. Also works here. 2 plus 2 factorial, which is 4 factorial. 4 times 3 is 12, times 2 is 24, and divide that by 2 to get 12. So we can write the first part of the function. 0 n plus 2 factorial 2. And one of the easiest parts to see of this is the x to the n. Here it's 0, x to the 0 is 1, x to the 1, x squared, x cubed. So x to the n. And then on the bottom, it's just n factorial. So we have 2 times n factorial, n plus 2 factorial on the top, x to the n. That's the general term for the Maclaurin series. That's basically it for today. So.